So let's do some definitions. So what does it mean for two lines to be parallel? What does that mean? Parallel lines. What do they look like?
They run together.
They run together and they're never going to meet. And what do we know about parallel lines? They have the same slope. Yep. So parallel lines, they will never ever intersect. And they have the same slope. And they're in the same plane. So in order for them to be parallel, they're on the same plane, same slope, and they're never intersecting. The way that we identify parallel lines in a diagram, so I'm going to draw a couple parallel lines. And I'm going to call this line M and this line N. In this unit, you'll see a lot more of lines labeled by that lowercase cursive letter versus two dots, just keeps the diagram a little bit cleaner. And parallel lines are marked with these little arrows. So if a line has the same number of these little kind of arrow indicators, then that's marking that it's parallel to another. And so I could have just put one. A lot of times they put two. Okay, so if I had 1 and 1, oh, those are parallel. The ones that have 2 and 2, those are parallel. I could have 3 arrows and it would match with another line that has 3 arrows so that we can mark several different parallel line sets in the same diagram. And the notation that we would write is that M is parallel to N. Okay, so that's our notation as we just draw those two little parallel lines. But we use that in our proofs, right? So M is parallel to N. We know that that means parallel lines. What are lines that are perpendicular then? Do those lines intersect? Yes, and in fact, they intersect in a special way. They intersect at a right angle, at a 90-degree angle. So perpendicular lines intersect at a 90-degree angle or a right angle. And they also have special things with their slopes. Going back to unit 1, their slopes are opposite reciprocals. And again, I'm going to give you a diagram and some notation. The perpendicular notation gets kids a lot. So for example, I could have line L be perpendicular to line M. And we can't assume anything from any diagram. So the diagram either would need to mark a right angle. And by the way, if this is a right angle, then all of these angles are right angles. Okay, so it's identifying one tells me all of these are perpendicular all the way around. Okay, so we can't look at it and assume it's a 90-degree angle, but if it shows a 90-degree angle, then they're perpendicular. Or if it gives us this information, that L and M are perpendicular. Okay, that's the notation for the perpendicular line. So we have parallel and perpendicular. Skew lines are a little bit of a tangent from our actual lesson today, but worth noting. Skew lines are just a good vocab word to know for geo, and it does come up every once in a while. So skew lines also do not intersect. So skew lines do not intersect. And here's the tricky part with skew lines, and are not parallel. Are not parallel. Now, if you're on the same plane, like a coordinate plane, if you're graphing, the only way lines will not intersect is if they're parallel. If they're even just a little bit not parallel, eventually at some point they would meet, okay? So the only way that skew lines can exist is if they are on different planes. Okay, that is the only way that this situation could happen, is that they are not parallel lines, but they also do not intersect. And so a visual of this, I could have a plane here, and then I could have another plane here. And if you kind of think about these planes, it's like this paper, like there's a plane here and there's a plane here, and they're expanding forever and ever, but they're never like meeting each other, okay? So I have these planes, and then on this plane, I have a line, and on this plane, I have a line, and they're not parallel, okay? But they will never hit each other because they're sitting on like different areas, okay? They're never going to crisscross these two planes. Okay, so it kind of goes along with parallel perpendicular, worth noting, but we don't use skew lines like in a proof. Our transversal, so this is probably a new word, and it's a super important vocabulary word for this unit, transversals. A transversal is a line that intersects two or more, many times more lines. Give you a chance to write that down, and we'll talk about what that looks like. A line that intersects two or more lines is called a transversal. So many times what we're going to see, maybe I have some parallel lines. We'll call this line M and that N. We can say M is parallel to N. And I could have another line that we'll call L, okay? And L is a transversal. L is a transversal. It intersects both M and N. Okay, transversal.
Is that M and then, is that thing next to the N in the notation for it?
Yeah. M is parallel line to N. Now, when two lines are cut by a transversal, it creates all sorts of angle relationships. These angle relationships are true even if it's not two parallel lines. We're going to focus on parallel lines, but we still can have these angle relationships even if the lines aren't parallel. You'll notice in the diagram here, these two lines, they're really line segments. They don't look parallel to me. Okay, they're just two lines and they're cut by this transversal. So just keep in mind in terms of the actual relationships, they don't have to be parallel lines. When the lines are parallel, then certain things are true about these angles. And that's what we talk about kind of more next class than we do today. Okay, So when two lines are cut by a transversal, there are all sorts of angle relationships that are made. So we have our interior angles and our exterior angles on this diagram. What do you think my interior angles would be? What angles are in the interior? Inside. 4, 3, 5, and 6. Exactly. So it's saying here are two lines cut by a transversal. And when we do that, we have some angles that are on the inside of the two lines and some angles that are on the outside, interior, exterior. So my interior angles would be 4, 3, angle 5, and angle 6. Okay, this is my interior, okay, in between the two lines. And then I also have exterior angles, which would be 1, 2, 8, and 7. And then we should also note this line here. This is the transversal in this case. And sometimes there's more than one transversal. Anytime a line hits more than one line, it's a transversal. Why is M not a transversal then? Why is M not a transversal?
Because it's only hitting one line.
Well, it cuts through one line, right? It's only hitting one line. Same with N. So M and N are not what would be considered transversals. They're just lines. But this line T is hitting more than one line, 2 or more lines. Okay, it's a transversal. These are my interior angles. These are my exterior angles. Okay. When you're ready, flip this page. So still with our interior and exterior, okay, here comes our special relationships. What happened here? I think my diagram got cut off here. It should still have T and 1, 2, 3, 4. The diagram got cut off there at the top if you want to redraw the top of that. It's the same diagram all the way through. So we have interior and exterior. We know that the interior would be 3, 4, 5, and 6 angles. A relationship that we have is same side interior. 3 and 5 would be on the same side of what? When I say same side, I'm saying the same side of what? If 3 and 5 are a pair. Of what?
Of the transversal.
Of the transversal, totally, yeah. So this transversal, when I say same side, I mean the same side of that transversal. Okay, so I have this transversal T, and I have angle pairs that are considered same side interior angle, which would be 3 and 5. What would be another same side interior angle pair? Or what else? Same side interior.
4 and
4 with, it's tiny, 6.
6, yeah.
And 4 and 6. So 4 and 6 would also be same side interior angles. Similar, here's again transversal T. We can have same side exterior angles. So let me give you an example. 2 and 7, they are on the same side of the transversal and they're on the exterior. So 2 and 7 would be an example. Or what?
1 and 8.
Or 1 and 8. Okay, so same side, when I say same side, I mean of the transversal. Okay, same side of the transversal interior or same side of the transversal exterior. Alternate, also could say opposite, okay, but most of the time noted as alternate interior or alternate exterior angles mean that we have T, and an example of an alternate exterior would be 4 and not 3, okay? 4 and 3 are not alternate interior angles. They're on opposite sides of the transversal, but they're connected to the same line here. These are actually a linear pair, or they create 180. If you can see, they're creating the line M. When we talk about alternate angles, we want opposite side of the transversal and also on the opposite line. Okay, so 4 would be alternate interior with 6. Yeah. Yeah, go quickly. So I have 4 and 6. What would be my other alternate interior angle pair? 3 and 5.
Oh, sorry, I was.
Yep. 3 and 5 here would also be alternate interior. Alternate exterior, so again, here's our transversal, again, exterior, so 2 would be an alternate exterior angle with, which angle? 8, yeah. So on the opposite side of the transversal and on the opposite line, and they both have to be exterior. Okay, so exterior, opposite side, opposite line. So 2 and 8. Or 7 and 1. Good. Okay, so those ones are easy just because in terms of identifying, because the name kind of indicates what's happening. They're on alternate sides or they're on the same side. The one that sometimes gets students is this last angle relationship, which is called corresponding angles. So again, here's my transversal. For corresponding angles, they're on the same side of T. So we're looking at either this side or that side of T. Corresponding angles means on that angle pair, one angle's interior and one is exterior. And just like alternate, they have to be on the opposite lines. So for example, 1 and 4, they're not corresponding. 1 and 4 are just creating this line here. They're what's called a linear pair. They're next to each other. When I'm saying one interior and one exterior, meaning I'm taking the interior from here and the exterior from this side, okay? So on the same side of T, we could have one example, and there's going to be many examples of corresponding angles here. We could have 4 and 8. 4 and angle 8. Or on that left-hand side, what would be the other set of corresponding angles?
5 and 1.
5 and 1. And what would be another set of corresponding angles?
3 and 7.
3 and 7, exactly. So on the other side, inside, outside on that same side, or angle 3 and angle 7. And what would be another? Would be the last pair. So we have 1 and 5, 4 and 8, 3 and 7, 2 and 6, because outside, inside, corresponding one's out, one's in. Angle 2 and angle 6. Okay, so one interior, one exterior on the same side and on opposite lines. Okay, now let's give ourselves a challenge. Flip this over. Okay. So first question I'm going to ask you is how many transversals are there in this image? How many transversals are there in this image?
Answer it.
Yeah, how many? I'm asking you.
2.
So I would say there's 1 here.
Oh, 4.
There's 4, yeah. There's 1 here because it's hitting 2 lines. There's one here that's hitting two lines. This is also transversal because it's hitting two lines. And then last, this is also transversal because it's hitting two lines. So now we've got a little bit of a challenge. It says, how many pairs of same side interior angles are in this diagram? So first, let me just note. So we said there are 4 transversals. Okay, so we're going to do this for each transversal. So for the orange transversal, okay, I'm covering up the rest of the diagram. What would be a pair of same side interior angles if I'm thinking about the orange transversal? C and F and interior. And what, say it again? E and D, yeah. So looking at the orange, on the inside, same side, I could have C and F, or I could have D and E. So on that orange transversal, I could have angle C and angle F, or I could have angle D and angle E. Moving on to the green transversal. Okay, there are more same side interiors than just that first one. Let me get a green pen instead of a green highlighter. What would be a pair of same side interior angles on the green transversal?
J and or wait, what is that? L and A.
L and N. L and N. Yep. Angle L and angle M. N. 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 And what would be my other same side interior?
K and M.
K and M. Angle K and angle M. Good. Now let's move to the blue transversal. What would be a pair of same side interior angles on the blue transversal?
L and C.
L and C and
J and A.
J and A are same side exterior.
Oh.
So remember, so here's my line, here's the two lines inside those two lines. So I have C and L, and then I have B and I. So even though it makes like a little triangle up here, the B and I are between the two lines that this blue transversal is hitting. So the blue transversal same side interior would be B and I, and angle C and angle L. And still have another transversal. I like to flip it. I don't know. I like to look at it this way instead of the other way. You don't have to flip it. I have this black transversal. Same side interior angles here would be?
B and
Black transversal, same side. So if
F, G.
F and N, yeah, so this is my transversal, and I'm saying these two are on the same side of this transversal on the inside. F and N, what would be the other one?
M.
E and M would be exterior, outside of the lines. Interior, so G with P. Tricky, huh? Okay, so what we were looking for there, probably should have given us a little same side on the interior. Okay, so here's the transversal, two angles that are on the same side interior. Now, we're gonna look for angles that are on the same, oops, I don't know why I drew two transversals there, on the same side exterior. Okay, so if this is my transversal, it's on the same side on the exterior. Okay, let's start with the orange transversal. What would be a same side exterior angle pair? A and H. What would be the other one?
D.
What was that?
D and E.
I love D and E, but they're same side interior.
G.
B and G. Yeah. So I have A and H, same side exterior, and B and G, same side exterior. So I have angle A and angle H, angle B and angle G. And let's now go to the green transversal. What would be a same side exterior pair? Outside on the same side of that green line.
J and O. I think it's a J, I believe.
J and O, yep. And what would be the other pair?
I and P.
I and P. Yep. And the blue line. Okay, so here's my transversal. On the same side of that transversal, on the exterior would be A and I, or I think it's a J. This is I. A and J. And what would the other one be?
D and K.
D and K. So A and J, an angle D, an angle K. Okay. And we have our last line, the black transversal. I won't flip it. You tell me. What two angles are on the same side of that black transversal on the exterior?
M and E.
M and E and?
N and F. No.
No. So now go to the other side of the
O
black
and H.
transversal. Yep, O and H. So I have M and E and O and H. Good. Now we're gonna look at alternate interior. So alternate sides on opposite lines, alternate, and on the interior. I'll get you started and then I'll let you do the other three lines. On O, what would be one set of alternate interior?
AC.
A and C are actually vertical angles from our last unit, like they're across from each other. So I have to go, here's O, and then here's O. Here's our orange line, and then here's the interior of that. Does that make sense? So now I'm on the interior, and which angles are opposite on the interior?
DC.
D and, yes, they're on opposite sides, but alternate has to be opposite sides and opposite lines. So D and, go to the other side, other line. Yep, D and F. And what would be my other pair?
EC.
E and C. Okay, so I'm crossing the line and I'm going to the other side. Okay, F and D, E and C. Angle D, and angle F, angle E, and angle C. So now see if you can find the alternate interior angles for the green line. And I'm not going to help you. Okay, I want you to see if you can get them first, and then we'll talk about that one. Massive glare. So what do you think on the green transversal? What do you got?
K and N and M and L.
K and N and M and L. Good. And blue transversal. Okay, alternate interior. So if I look at this blue line, I and C and
L and B.
L and B. And on the black transversal,
I forget which one that is.
sorry, right here. So black transversal,
N and G and P and F.
N and G, P and F. Good, you're getting it. Okay. And just like alternate interior, we also have alternate exterior. So two lines, transversal, one side and the other, and again on opposite lines there. So alternate exterior looks like this. So on my orange line, I am only looking at the exterior of that orange line. What would be an alternate exterior angle pair?
B,
B and H and
A and G.
angle A and angle G. Yep. Okay, you find the rest of them in that diagram. Hint, there's 6 more. Looks like there's been on the rest. On page 3. Okay, so green transversal. Green transversal, what's a pair of alternate exterior? J and P and I with O. Yep. Angle J and angle P, angle I and angle O. Blue transversal, what'd you get? Top transversal. Up here
A,
with,
and K and D and J.
yep, and K. Good. And last, black transversal. Mm-hmm. Yep. Angle H and angle M. Okay. I do see that it didn't ask us, how many of these gonna just like name 2? We're just gonna practice naming all of them because this is all we have today in terms of time. Like, we're gonna finish this page and I'll let you continue practicing this. And I think it's worthwhile to find all of these so that we can start feeling really comfortable identifying which is which. So the corresponding angles is going to be a little bit more of a task than just the alternate interior or the same side angles, because there's going to be some more of them. So corresponding angles, remember, is the tricky one. So corresponding angles means I have one inside and one outside angle, and they're on the same side. So it could look like this, or it could be this pair here on that same side. Okay. So for each transversal, I'm going to have 4 corresponding angle pairs. Meaning on the orange transversal, there are 4 corresponding angle pairs. What would the angle what angle would be corresponding to angle A? Say it again.
D.
Not D, they're inside outside, but it needs to be inside on the opposite line. So it'd be A with, you're going this way. So if I'm on the orange transversal, I have to be same side and then outside, inside, A and E. So what would be the other pair on that side?
D and H.
D and H. Yeah. So on one side of that transversal, I have angle A and angle E, and I have angle D and angle H. Okay, but I have 2 more pairs of corresponding angles on just that orange transversal. So on that orange transversal, I have the other side of the transversal, so which also has corresponding angles. What would be a corresponding angle pair on this side?
Yeah,
B and F and
CG.
C and G. Good. So that orange transversal has 4 corresponding angle pairs that live related to that orange transversal. On the green transversal, let's look at the outside first on this side of it. What would be a corresponding angle pair over there?
JNM,
JNM and
KNL,
KNO, and on the other side of that green transversal, I and N or L and P. Okay, so again, I have 4. Angle J and angle M, angle K and angle O, angle I and angle N, angle L and angle P. Flipping my page, blue transversal. Let's look at just this side. What's one corresponding angle pair? What do you think? You can cover up this side too if it helps you. What would J be corresponding with there? J and B or A and I? Angle J and angle B, angle A and angle I. And on the other side, angle K with angle,
C,
yep, and angle L with angle
D.
D. Yeah. Last transversal, black transversal, if I cover up the inside of that, what would O be corresponding with?
G,
O and G, and P and H. On this side, M and F, and N and E. Okay? So we have angle O and angle G, angle P and angle H, angle N and angle E, and angle M and angle F. How many pairs of corresponding angles do we have in this diagram?
a lot.
Lots of them. 4 for each transversal. And so it's a good idea to kind of keep in your mind. So what I have 16, okay, corresponding angle pairs, but also the idea that there's 4 for each transversal. And if we go back, how many alternate angles, alternate interior or alternate exterior? Total, we had 2, 4, 6, 8, okay? How many did we have for each transversal though? We had 2. 2 for each transversal, which is important because like if you're looking at a diagram and saying list all of them, then you should know based on how many transversals there are, how many angles you should be listing. Okay, if there's only 1 transversal, there's only 2 alternate interior, there's only 2 alternate exterior. But there are 4 corresponding, and there's only 2 same side, only 2 same side interior, same side exterior. Same idea here. So 8 or 2 for each transversal. Okay. So that's just kind of a good concept to have in your mind that for each transversal, there will be 2, 2, 2, 2, 4 corresponding. Vertical angle pairs, I don't know if we'll go through all of them. Vertical angles, that's from last unit. 2 lines hitting with a transversal. Vertical angles, okay, they're congruent to each other. We learned that last unit. They're the angles that are across from each other. Okay, so I have vertical angles here, and I would have vertical angles here. Okay, so it has nothing to do with the 2 lines. Okay, it's all circled around 1 line and the transversal that's hitting it. Okay. So like on the orange transversal, Okay, the orange transversal hitting the blue line, what angle would be vertical to angle A? What do you think? Okay, so I have an orange transversal, it's hitting this blue line, A, and what would be a vertical angle pair?
E? No, C?
A and C.
Oh,
A and D would be a supplementary angle pair. If we go back to last unit, they're creating a line. A and C are across from each other. So A and C are vertical angles. What about B and D? Are they also vertical?
yes.
Yeah, okay. So from that orange transversal where it hits the blue line, so again, it has nothing really to do with the fact that this is hitting both lines, but they do exist there. So we have angle A and angle C and angle B and angle D. And what about angle E? What would that be vertical to?
G,
And angle G and angle F with angle
B.
H. Yep. I think we'll leave that there. Okay, we'll just name one transversal because what's going to happen is like when I go to do the blue transversal, I'll have those same vertical angles. Okay, so it's a little bit different when we look at vertical angles. It's not switching with each transversal. It's basically just every time we have this cluster of 4 angles, we have 2 vertical angle pairs. Okay, but notice like on this blue line, it's going to be the same 2 vertical angle pairs there. Okay, as it was when we looked at it and looking at it from the orange side. Okay, so what you are going to do, I don't think I put it in here. I think I put it in your homework. Okay, so tomorrow what we're going to be doing is we're going to be taking these angle relationships and we're going to be applying them to parallel lines. And there's some special things that happen when we have parallel lines. What you're going to do for homework tonight is you're going to just practice identifying what angle relationship you have. So it says at the top, you either have alternate interior, same side, they might all be interior for this set too. There's no exteriors listed, or corresponding. You may have exteriors actually, because I changed some of the angles as I wrote them down. So for the first set, it should be similar to what we did in notes. So I'm gonna look at 2 and 4. Now what's tricky here is it doesn't tell you what transversal you're looking at. So you have to make that decision. 2 and 4 are both connected to this C line. So that's the transversal. That's how I know, like what line are both of the angles touching? That's the transversal. And then I decide what's their relationship. So what would be the relationship for 2 and 4? This is the transversal I'm looking at.
Wouldn't that be same side and
They're on the same side. This one's exterior, this one's interior.
Oh, alternate in.
They're not alternate, they're on the same side. One's out, one's in. What's that called? It's the special tricky one. Corresponding?
Yeah, corresponding.
Yeah. Okay, so that one's tricky. Okay, and when I look through this, if I jump to like 3 and 11, so again, 3 and 11 are both connected to this line. So this is the transversal. Okay, so looking through that. Now it gets trickier when it gets to the bottom diagram. Okay, and that's why I'm giving you time right now to kind of look through it and ask questions. When I do this bottom diagram, I have to follow the letters to figure out which angles I'm talking about. It gets super tricky. So it says STU. So if I look at my diagram, STU would be here. And SZX. So SZ here, X. That's this angle. Okay, SZX goes SZX. This angle. So then I look at that, and again, both of these angles are on this line. And these are also corresponding. One's inside, one's outside. Okay, but it definitely gets harder in this diagram. And so what I recommend you do is not what I just did, which is mark it in pen, but what I think is helpful if you have a pencil is like do those dots like I just did, and then erase it. And then for the next one, do new dots Does that make sense? So you can really visualize where those angles are. Okay, so that's what we're working on right now. I am going to change, I don't think I've changed this class at all. I had been putting the keys in the slide deck, but I feel like some people aren't going to the slide deck to check their work. So what I'll do from now on is the keys will post in Classroom, but under the announcements. So on the stream, when you first go into the classroom, you can choose to post an announcement or like an assignment. So it won't be an assignment, it'll just be an announcement on the very front page of Classroom. So any keys for warm-ups or any of the notes, because I've also been putting the completed notes in there each day, but I just kind of feel like people aren't going back to the slide deck later in the day. So I'll just put those in the stream. It'll be easier to find too.
So when we're at home Thursday, Friday,
Yeah.
if we're on the Zoom, do we need to watch the notes too or no?
No, and I've been trying to